The vast majority of scientists thought that the universe was formed by a significant explosion known as the Big Bang. Until then, all of the universe's energy was concentrated in a single, exceedingly tiny place smaller than a subatomic particle such as a nucleus. It has yet to solve the puzzle about what happened before the Big Bang. Looking very far away is the only way to glimpse back at when these items were formed. NASA knew that the Hubble wasn't large or cold enough to detect the feeble heat signatures of these distant objects. So the James Webb Space Telescope was developed. Initially, the JWST was planned to view a time of the universe's history that we had not seen previously rather than the start of the cosmos. They needed to view the earliest things formed when the cosmos cooled following the Big Bang. How did the small temperature wave they detected evolve into galaxies? Precisely when or how the cosmos created the first stars and galaxies? Amazingly, this world-class telescope is working according to its expectations. In fact, scientists are still in shock as the James Webb Telescope just found what came before the Big Bang. Only a week after its first images were displayed to the public, a scientist who studied the data stated that the JWST may have discovered a galaxy that existed 13.5 billion years ago. Naidu and colleagues, a group of 25 astronomers from across the globe, have published their results in a scholarly publication. They discovered a galaxy known as Glass Z13, which was discovered 300 million years after the Big Bang, nearly 100 million years earlier than anything previously discovered, according to Rohan Naidu of the Harvard Center for Astrophysics. "We might be staring at the farthest distant starlight ever observed," he said. "The farther away an object is from Earth, the more time it takes for its light to reach us. Thus, looking back into the distant cosmos is like seeing the deep past." Though Glass Z13 existed in the early cosmos, its exact age is uncertain, since it might have originated at any moment within the first 300 million years. Glass Z13 was discovered in early release data from the Orbiting Observatory's primary infrared imager, NIRCam. Still, the finding should have been mentioned in NASA's initial image set released last week. The galaxy materializes as a blob of red with white in its center, translated from infrared to visible spectrum, as part of a larger view of the distant universe known as a deep field. Astronomy records are already disintegrating and more are fragile. NASA's top scientist Thomas Zurbuchen tweeted, "Yes, I like to rejoice only when scientific discoveries pass peer review, but this seems extremely promising," he said. "So that gives us confidence," Naidu said of another team of astronomers headed by Marco Castellano, who worked on the same data. Naidu and colleagues went through this distant universe's infrared data looking for a telltale sign of very distant galaxies. All photons or packets of energy are immersed by the neutral hydrogen of the cosmos that sits between the object and the viewer below a particular infrared wavelength threshold. By analyzing data obtained via multiple infrared filters targeted at the same area of space, scientists could pinpoint where these drop-offs in photons occurred, from which they deduced the existence of these most distant galaxies. "We examined all of the early data for galaxies with this distinctive signature, and these were by far the most persuasive signatures," Naidu said. "One is Glass Z13, while the other, less old, is Glass Z11. The study is now on a preprint site, meaning it has yet to be peer-reviewed. Still, it has already sparked interest in the worldwide astronomy community. In particular, the team plans to ask Webb supervisors for telescope time to conduct spectroscopy, an examination of light that exposes exact features to calculate its precise distance. You will be intrigued that the most distant and oldest starlight study has been verified. The two ancient galaxies were discovered billions of light-years beyond the Abell 2744 galaxy cluster. These initial galaxies seem significantly different from those seen in visible light around the Milky Way by telescopes like the Hubble Space Telescope. The two galaxies discovered by GLASS JWST Early Release Science Program and Cosmic Evolution Early Release Science Survey, or CEERS, lived 350 to 450 million years after the Big Bang. GLASS and CEERS papers have already been published in the astrophysical journal Letters. Both galaxies are intriguingly less than 1% of the size of our Milky Way galaxy, spherical and brilliant and actively forming stars. They were supposed to produce stars just 100 million years after the Big Bang. This understanding was only attainable because of JWST's ultra-clear infrared photos. These galaxies are significantly different from the Milky Way or other massive galaxies we see around us now, said Tommaso True, a co-investigator on one of the Webb programs. Everything we're seeing is all new. The JWST's first findings need to be clarified for scientists. These galaxies would have had to start forming maybe 100 million years after the Big Bang, said Garth Illingworth of the University of California, Santa Cruz. This primordial universe would have been 1/10 the age of the present one. Nobody imagined that the Dark Ages would have ended so early. One notion is that these bright galaxies are enormous with many low-mass stars. Another is that they're less massive yet have fewer brilliant so-called population 3 stars. If the latter idea is correct, JWST has already discovered the first stars. This is a completely new chapter in astronomy, like it's discovering something or a lost city you didn't know about, said Paola Santini, the GLASS JWST paper's 4th author. It's mind-boggling. What's more, Webb has now fulfilled its most important promise to date. A new unpublished paper states that the telescope has discovered and confirmed the 4 oldest galaxies that date back an average of 400 million years. Some 13.8 billion years ago, which occurred earlier than the Big Bang. This is how the galaxies would have looked 13.4 billion years ago, explains prominent scientist Brant Robertson of the University of California, Santa Cruz's Department of Astronomy and Physics. With Webb, you can turn back the time and see them as they were then. We're attempting to achieve that by collecting these observations. We're gazing back in time. The latest discoveries suggest that galaxies formed not just 325 million years after the Big Bang, but that there are likely earlier ones as well, bringing scientists closer to establishing the exact birth date of the earliest galaxies. This finding is the product of work by the JWST Advanced Deep Extragalactic Survey, an international team of more than 80 astronomers from 10 nations who studied a deep field of 100,000 galaxies initially observed by the Hubble Space Telescope in 2010. Many of the galaxies' apparent size, faintness, and distance indicated that they were very ancient, but Hubble, which sees mostly invisible light, lacks the gear to photograph them clearly or estimate their age. This is because visible light from such a great distance cannot readily penetrate the interstellar dust. Infrared radiation, on the other hand, penetrates the dust. This enables Webb, a telescope that detects radiation at that frequency, to view as far away as 13.6 billion light-years. Using 2 instruments on board the Webb, the Near-Infrared Camera, NIRCam, and the Near-Infrared Spectrograph, NIRSpec, Robertson and his colleagues studied the redshift of 4 galaxies that seemed exceptionally tiny, dim, and distant. The wavelength of light emitted by objects as they travel towards us in space is compressed, pushing it to the bluer end of the visible spectrum. As things travel away from us, the wavelength is extended, moving toward the red end. The more crimson an item seems, the more away and colder it is in our ever-expanding cosmos. The NIRSpec was used to identify the galaxy's chemical composition and their mass, which was determined by the scientists. Hydrogen and helium were the primary components, since the early stars inside the galaxy did not have enough time to create heavier elements, according to Robertson. He says they are somewhat metal poor, meaning they contain fewer heavy elements than the Sun. Over the next 2 decades or more that Webb is scheduled to be in operation, these results bode well for discovering even more massive objects and older galaxies. Interesting, right? We hope you enjoyed watching this video. If yes, we're sure you would like this next video here. Thanks for watching.